Hi,
Hey,
Sakul. Good
Jason.
afternoon. Hi, Pankaj. Good afternoon.
Good afternoon, sir.
I just snap it. Hi there.
Why don't we give everyone another minute or so, see if some more people join.
So I wanted to share with you something
Okay.
that I was looking at, how the uh, AI libraries are being written and how people are coding for performance in the most portable way, and what can compilers do and what do libraries need to do.
Mm-hmm.
And some of this was triggered by, the introduction draft that you haven't seen that Samsung guys have circulated with a few people. Okay. So I was just reviewing and commenting on their draft to help them get started on their contribution to the big doc that we are working on the white paper. Okay.
Okay.
One of the things that they bring up is, you know, what's the place for compilers? Hey, Gaurav, the man from Hawaii himself, man.
Oh, hi, good
Aloha.
afternoon. Sorry for missing last week. I
No
was out.
problem, Graf. Hopefully sounds like it was a vacation and hopefully it was wonderful.
Indeed.
They're never long enough though. That's the only problem with vacations.
Yes, that's for sure.
Especially to Hawaii.
So yeah, uh, I was telling Jason that the Samsung guys are uh, talking very carefully about you know what is it that needs to be done by compilers and what's to be done by libraries. And so I read that stuff and it kind of made me think, and then I gave my feedback and then was done. And then 2 weeks later, I run into a neighbor who works at Intel Labs, and he's recently written, the one of the kernels for the new microprocessors that are coming out. And he was telling me some really advanced math called space filling curves that they used and published a paper about it. And we had like an hour and a half discussion on it, just standing outside our houses. And so I was reading his paper. And um, yesterday, then after that, there was a seminar at Stanford in the linear algebra and optimization group last night. I just, had done with my day's work, so I thought I'll go listen to a talk. I was over at Stanford, and people from Cerebras and a couple of other interesting companies and people who, wrote the HPC and computational kernels for many, many commercially successful libraries. A couple of them, all former HP Labs people. We saw each other by chance. And so we had dinner together and a lengthy discussion, and it went into some of these topics, which is, what's going on around small bit floating point like FP2, FP4, FP16, and the innovation that is going on to actually make it work correctly. And there's no way many of them and most of them believe that compilers would ever have figured this stuff out, because the human skill you have to use to actually use that few bits and produce meaningful and consistent floating point answers, it requires decades of deep skill. And if you haven't been doing this for a living, you haven't a clue what goes wrong. So, um, so I came to this conclusion. personally, and I still want to work on this a little bit, that I think, our team, which is trying to build APIs and kind of trying to figure out these lowering compilers and what will be behind them, one of the ways to think about it is that close to the new machines, right? Where, there's a revolution in mantisas, exponents, and, there are like ideas of people like Gustafsson that are not yet implementable using today's hardware. Hojan is here. Um, and these people will keep innovating in this space. I don't think we are going to stop for another 5-10 years at least. So things like matrix merge and search, uh, uh, they are libraries that we have to generate code for. And the question is, how do we give them the freedom to innovate while still using the machinery that Google, for example, in OpenXLA and all the open frameworks like SQL frameworks and linear algebra frameworks, soon graph frameworks will put out. And so I'm learning new stuff. One of the things I'm learning is there is this thing called GraphBLAS out there that is getting used a lot. And so I plan to look into that. But it looks like, we'll have compilers at the top, we'll have libraries at the bottom, and roughly the spot at which we want to deliver our API is where the separation boundary is. We want to compile down to the highest level that the libraries want to meet with really, really nice implementations that are, catering to their backends, like the PIM, PNM, and new accelerator backends that people keep innovating on. And I think this framing is consistent with how Gaurav and Srihari talked, it's consistent with Hojin and Samsung team, what they're writing in the introduction. And I think that we need to uh, capture it. So Gaurav and I will update, the practice and principles document, which roughly got here, but is not as explicit about this as I wish we were. And so in the roadmap to getting the CMS CXP principles and practices document, one of the things, getting it to 1.0 and out this quarter, one of the goals I have is, figure out those ideas that are aligning well with what DCC people are saying, this team. And let's, get a few things done and then get to work on APIs where I think that the implementations will largely be done by accelerator architects. And the hardest thing we will be doing is using DPUs and front ends like PNM and DPU front ends to actual new power efficient floating point compute hardware to scale it out and deal with things like partitioning and placement of function and data. So let's get to it, for all the right reasons. I think this is the thing to do and how to approach it. Just some quick thoughts to get us going today.
Yeah, thank you, Pankaj. Any comments or feedback?
I will take that as strong agreement.
I think that seems reasonable.
Yeah, true.
So Jason, you own the agenda before we
So
dive.
yeah, what I had on the agenda is, we talked about the XPI a little bit more last week, and I know some folks weren't able to join. I don't think we actually finished. I don't know if you want to give a quick recap for those who couldn't join and then kind of jump into continuing, or if you have another suggestion.
No, I think we can do as you suggest.
Okay.
What else do we have on the agenda, Jason?
The only other thing is to do a status check on the white paper. I know Hojin is working away fastidiously, and we'll have something to share soon. I don't know if anybody else has any update that they want to share on anything they're working on.
I just want to tell Hojian, I think, the discussion we just had was entirely triggered by some of the things that he and Samsung team have written. You guys are doing really well. You're digging deep. You're really sharing your learnings. And I hope you can share it more broadly very, very soon, like this week or next week. What's your
Actually, I already updated the introduction in the Google Docs. So
Oh, fantastic.
yeah. So I can I think we can talk about that draft after the Pankaj's presentation.
Okay, would it make sense to spend 5 or 10 minutes just taking a look at the introduction now,
now?
and then Pankaj can then take the rest of the time?
It will be very good context, actually, Jason,
Okay,
if
I think we
Hojian
should do that.
agrees. Yeah.
Yeah, Hojin, do you want to share? Do you want me to share?
Could you share the document Google Docs?
I can.
Yeah,
Yeah,
yeah, yeah. Thanks.
let me bring that up. All right. All right, let me share. I finally have it open. Sorry for the delay. All right, let me see if I can make it a little bit bigger. How's that size?
Yeah, good.
Yeah, yeah,
Okay.
yeah. Yeah, so I submit to the introduction to our DCC work stream. So yeah, so I updated the introduction to clearly define the problem space, and I structure into 5 key areas. So first thing is regarding the memory and energy challenge, and in this chapter I highlighted that modern AI workflows are shifting from being compute bound to memory bound. Yeah, and the working set of modern LLMs often exceed the local memory capacity of GPUs, forcing systems to frequently fetch data from off-chip sources. So this isn't just a performance bottleneck, it is becoming a critical energy crisis as moving data consumes significantly more power than the actual computation itself. So could you scroll down to second chapter? Yeah, yeah. Oh, yeah. So in second chapter, on architectural responses and NDC, I acknowledge that while the industry has made great strides with HBM and high-speed interconnects like NVLink, but these technologies still rely on moving data to the processor. I argue that to fundamentally solve the energy issue, we must shift the paradigm to near data computing, NDC, moving the computation to where the data resides, like PIM or PNM or smart SSD, rather than just moving data faster. Uh, and yeah, could you scroll down to third chapter? And in this chapter, I pointed out that today's major AI frameworks are heavily optimized for GPU-centric execution models, which make them rigid when introducing new hardware. Uh, Currently, integrating a NDC device often requires custom vendor-specific APIs and runtimes, and this leads to severe code divergence and fragmentation, and making it difficult to maintain a unified software stack across different hardware vendors. Could you scroll down to for a chapter? Yeah, so in this chapter, I analyze the trade-offs between library-based approaches and compiler-based approaches. Library-based approaches is offer flexibility through pre-optimized kernel. Yeah, and it is it includes kind of CU plus CUDNN and 1DNN, something like that. And compiler-based approaches offers the maximized performance through graph analysis. It is including the OpenXLA and Glow and something like that. So in this chapter, uh, I suggest that hybrid model is essential for NDC. Hybrid model is mixture of library-based approach and compiler-based approach. So we need the compiler's ability to identify offloadable subgraphs while leveraging robust libraries to execute operations on the memory device. And in final chapter, could you scroll down to final chapter?
May I comment on this before you go to the final chapter?
Oh, sure.
So I think, Jason, if you scroll back up to that diagram, one of the learnings I had, as I was reading this and researching a little bit to give feedback, is I actually ended up looking very closely at some of the documents Intel have published on one API. And it was quite interesting in this diagram, if you look at the top row, where one API ends up. It kind of lives at the intersection of these approaches and exemplifies the idea of what is a representative hybrid stack. So to me, that was thought-provoking because I thought about it quite a lot. And then as I started to read some of the Intel papers, like the work that they do very deeply to implement a very nice MKL, mathematical kernel or matrix kernel library, and then the work they do in compiler layers up the stack, which lines up well with the rest of compiler work in the industry. So it seems to me that, Hojin, what you're recommending would benefit from us understanding where Intel chose to do that boundary between where the compiler approach stops and the library approach starts in their stack. We should critique it to see if we like every choice they made, or some of the choices they made could be improved. And we should invite Intel people to talk to us as well.
Yeah. I agree about your opinion. Yeah.
Yeah, I think that makes a lot of sense. And certainly if we have suggestions, we can work on getting those people invited.
So can I do final summarize?
Yes.
No, I have one more topic.
Oh, okay.
Yeah.
With your permission, I want to discuss one more topic here. I think, one of the questions we will find ourselves asking is what is different between the work that we used to do when the only thing we could do at scale was to involve I/O operations like RDMA. Now that we are going to have a very large number of memory semantic interfaces, and we don't have to go to I/O domain to do operations at scale. What are some optimizations and alignments that we need to enforce at the interface between the compiled part and the library-based implementation part? And I have a proposal that I would like to show you in one slide later, in which I advocate, and I presented this at NVIDIA on December 10 and at SK Hynix on December 11. And it's being widely discussed in OSU circles that the interface must be algebra based, that where the compiler ends and the library begins, the things you ask the library to implement must be operations in some algebra, like linear algebra, relational algebra, or graph algebra. Those are the three that I'm fond of. And this is what we wrote in, Gaurav, you remember, in the CMS CXP Principles and Practices white paper. This was the conclusion we came to many months ago, actually. Yeah.
Yep.
Yeah. That's my final comment on this. But this was, I have to thank you, Hojin, for writing very clearly, and it gave me a lot of food for thought in the past few weeks.
Yeah, this is fantastic. All right,
So
let me go to the next section.
actually, before the release of this document, Pankaj and some help us to the writing. So thanks for Pankaj and some. And yeah, and finally, uh, this chapter is cover of this document. I clarified that this white paper does not propose a proprietary solution for a specific product. Instead, it aims to define a common problem space and the set up architectural design principles for the industry. So our goal is to establish standardized way to integrate this heterogeneous device so that we can minimize code changes and foster a healthy ecosystem. So this is the introduction, and actually I added the uh, some uh, some draft for the NDC API. So could you scroll down to another chapter, NDC API chapter?
So which chapter am I going to?
I think below the pictures.
Below pictures. Okay.
Yeah. Yeah. So in this chapter, yep, this chapter is to be updated, and my plan is to update this section shortly with concrete examples that can serve as reference implementations for our common computing interface goal. So I intend to demonstrate how we can abstract heterogeneous memory devices using two specific use cases. So first is LLM decoding with the executors, and second is the files offloading. And the files offloading is the subject uh, releasing in last OCP Global Summit. So I think it can be the good example for our NDC API implementation. Yeah.
Yeah, it's good.
Hojin, thank you so much for working on this and for integrating it into the document. Any other comments or feedback for Hojin? I know nobody's had a chance to read it yet, but everybody will, I'm sure, will take a look at it in their time.
Mostly a listener here. Just a comment, a question. The library versus compiler based approach, isn't it true that, of course, the library-based approach is better, but it takes a lot of a mature library plus the domain specific, even domain specific uh, design. So isn't it true that the best is always library plus uh, compiler approach? The hybrid approach is always the preferred if possible. Is
I
that true?
think, if you think about historically, what used to happen if you look at MPI library, which is the oldest library in high performance computing, right? Instead of there being a compiler in front of MPI library, there was just the programmer. So most programmers of MPI since the 1980s, when it came out, used to directly code to the library's API. And some of this has to do with the design choices that were made in these libraries' APIs that made it impossible or very difficult or very poor performance to target those APIs using compiler backends. Because those guys didn't think about how multipass compilers uh, uh, based on LLVM and other modern technology, like in Calcite for database compiler and LLVM for daily compilation, and also, some of these uh, advanced multipass compilers for linear algebra that works on loop and indices, how they actually do rewriting. That was not properly thought through. I was there at the time when these things were coming up very rapidly, and their primary concern was portability and performance, but it was mostly performance as extracted by the programmer themselves doing all the hard work. So I always, even when we used to program Intel Paragon and IBM SP2 and such supercomputers in early 90s, I used to think this is the assembly language of parallel programming. Message passing felt like assembly language of parallel programming. And you know that I say message passing because MPI stands for message passing interface. So it never had any thought about what are you actually computing. It was mostly about how to use the communication network in the scalable system to move a lot of data around. And it's completely the opposite of what you should be thinking about. So I'll show you some example of how compiler thinking is very different from library thinking. If you're the user of a compiler, you do not get into that kind of a mess. You think very cleanly about the problem you're solving, and you let the compiler do the optimizations. On the other hand, if you're a user of libraries, you inevitably get into a lot of the business of, how do I do this or how do I do that efficiently as a programmer? And so you try to be a very good library user. I think you might agree with my comment there.
Further question on that. So my personal impression, at least, is the reason the library thinking is in the ML workload is effective is for the Python world, there's not a very good top to bottom compiler. For example, Julia, scientific computing, for the actual scientists, they're able to really do this so-called GPU programming, which compiler is very effective from top to bottom. For Python, that's simply not there. Chris Ladner is creating the modular compiler framework, which will change that. However, before that's become reality, for Python-related workload, which is most of the AI workload, that's why library thinking is still effective, at least.
I mean, you look at PyTorch compiler, and it does not quite follow what you're saying, because those programmers are not programming in low-level pandas or NumPy, they're programming using a higher abstraction, like mostly using collective communication. And now, with the introduction of symmetric memory, they're using fused collectives. But they, in many cases, they are not programming to low-level libraries. Only people who program on workstations or in uh, initial learning on a single machine, they use a lot of the libraries. But people who are programming scalable systems are using higher level abstraction.
Yeah,
At least,
that's my understanding. Because of that, when it comes to efficiency on the hardware level, it's not as efficient as Julia, for example.
oh, I see. I understand your point better now.
Yeah, then when you speak about compiled languages, do you also include interpreted languages like Julia, R, Python? So all those are considered as part of compiled languages? Was a question to
I,
Hojin. Yeah.
I think, Sakul,
Yeah.
maybe I can answer your question. Okay.
Okay. Okay.
Most functional programming languages are technically interpreted languages with just-in-time compilers. Okay.
Right. Right.
So what that means is that there is a internal notion of a abstract virtual machine to which the interpreter works. And then there is a just-in-time compiler that takes the critical portions of the code that is generated, like in Java case, that might be bytecodes. And the just-in-time compiler will turn some bytecode into machine language and might leave the rest of it to be interpreted on top of JVM. So many languages, including JavaScript, Java, I think Python as well, they work like that.
Yes. Yeah. Okay. Yeah. Same.
Can I add some answer? So, in that chapter, I think the compiler is the ML compiler, which is optimize the AI workflows, optimize the AI workflows by graph level, some kind of kernel fusion and something like that. So I think it is quite different with the uh, interpreter level compiler like Python and Julia, I think.
Exactly. It's more like the GLOW compilers, graph lowering compilers that Gaurav introduced also, right? In fact, it says there in the NDC API section.
Yeah.
Okay.
All right, well, great discussion. And again, thank you, Hojin, for posting this. This is excellent. Anybody else have well, first of all, any other comments or questions on what was shared so far?
Jason, before we
Yeah,
leave this agenda item,
yeah,
can we just review writing assignments very quickly from this document?
we can.
Let's just make sure that we are all committed to working on this now
Right.
that the introduction is in. Yeah.
Yeah. So if I skip to this existing framework section, I think Gaurav was going to work on something for OpenXLA. Sam, who's not here today, volunteered for Triton and PyTorch.
Just one sec.
Yeah.
I want to, I know Som isn't here, but one of the suggestions that I have received through recent discussions is that rather than talk so much about a particular framework like Triton, Triton is extremely important, by the way, but the core concept there is something called tile programming. And what we need to do is make sure that rather than rely too much on a particular piece of software, these things come and go. We should introduce a concept that will be lasting concept. So in this case, what I would like to do is you can put my name there, and also in the title there, uh, add the words Triton and tile programming, or tile programming and Triton
So is
would
that a
be.
subsection you're suggesting
No,
under?
just 3.2 itself. I think that the title should be tile programming and Triton.
Like that, and
Yeah.
replace Sam's name with yours?
No, add my name to there.
Okay.
Yeah. Som will still do the writing, I think.
Okay. All right.
Yeah.
Let me
I'll
put
just
Sam
make
first.
sure that, yeah, please. I just want to make sure that, we don't lose the forest for the trees.
Yeah.
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 Yeah. Go ahead, please, Jason.
Okay. So then if we kind of continue through the list, Sam had volunteered for working on accelerated programming interfaces section. I don't know if he may need a little bit of help with all these.
Yes.
But maybe he can get the initial section started, and he may know a little bit about one API or be able to get some help on one API, but certainly CUDA, ROCm are there.
So
Then,
Jason, again,
yes.
over there,
Yep.
I think because of the discussion now that we have an introduction and we know how we want to approach this section, the importance of one API exemplifying the hybrid approach, I would like to, I propose that we change the title of 3.71 to say as much, one API and the hybrid approach. Okay,
Absolutely.
and in this section, I think we should see if any of the people on the call want to help Som in the writing, people who are extremely familiar with this.
Yeah. It gave me another number when I hit return.
You can
I'll just
add
leave it
my
here for
name
now.
as a second name,
Okay.
but I do want someone who programs in one API as the first author here.
Anyone want to volunteer? Okay. All right, let me go ahead and move forward. So we have a section 4 on existing libraries with a bunch of notes from a while ago that can certainly be translated into some text. And then we have some sections here. Sakul has volunteered to do memory allocator, Gaurav OpenCL, MPI libraries from Sakul again, and then I have the SNEA CS API library. So I will work on that. And then let me see what else we got here. Then we move to
Just one sec, Jason.
Yep.
In that one,
Yep.
we need to broaden 4.3 to because I think our intention is to borrow memory pooling concept, which is very well developed in one API from one API. At least that's my bias, is to inherit the good parts from these APIs as much as possible rather than create our own. Okay.
Sure.
So again, in this section, I would like to generalize the title to be memory allocator, memory allocation and pooling. And Sakul, if you are open to this idea, I would like to collaborate with you and bring in some of the goodies from one API.
Okay, absolutely.
And then, Jason, was there another section under 4?
There is yes, there is another section, I believe, under data formats, of section 5. And so
I
we've
think
got
it's
Onyx, Arrow, Substrate, and
yeah.
HDF5.
Sorry, 4 is missing one section in my opinion,
Okay.
which is about moving, copying, and sharing memory. So it should be the new section 4.4.
Oh, you want it to be up above? Okay.
Yeah, right next to memory allocation.
Okay.
Because, like if you read CUDA documentation, CUDA mem copy and some of the memory allocation APIs are discussed very early in the documentation.
What did you
And
call it? Moving, copying, and
sharing.
sharing. Thank you.
Okay. And I think here, the best thing we have in the industry right now, outside of CUDA verbs, is SDXI from SNIA.
Mm-hmm.
And the CXP team and CMS went through extended liaisoning activities with the authors of that. Gaurav, you remember last name Shyam Iyer, right, from Dell?
Yep.
That's right.
Yeah. So I think, we think that their concepts for moving data between address spaces are like in the form of what do they call them? Source context and destination context, or similar words, right, Gaurav, that they describe to us?
Yes.
They have a good, mature concept that appears to work well inside the system and needs some extension by OCP team here to generalize beyond single address space. They had some ideas, but they were not mature when we talked to them at the end of 24. And we haven't talked to them for the most part in 2025. So what I would like to do is catch up on where they are. Have they made any progress that we have not while we were not watching? And then if there are still gaps, we want to address that.
Mm-hmm.
Okay, so this, again, I would like to be the second author on this, mainly because I am in my day-to-day work not actively using these APIs. So I humbly request if somebody is a little bit more familiar, please take on the primary author responsibility.
All right. Well, everyone can think about it, and hopefully someone will come and help contribute on that.
Thanks, Jason.
Yep. I'm not sure why the tool moved 4.5 down to the next page, but it did. It's all good. We'll work through those as we populate more of the content. Then in section 5, we have these
Jason,
data
again,
formats.
sorry,
Yep.
I have too many opinions today, but
It's all good. It's all good.
let's go through this a little bit. So
Yeah.
4.6, I think again we should change the title a little bit. And again, Sakul, seeking your permission on this. We should emphasize that the main contribution that MPI libraries bring is a widely accepted interface to collectives. And so both CUDA through NCCL and MPI through MPI Collective Communication Library are the most widely used standards for programming large-scale system. And both the CUDA section and should be renamed to CUDA and NCCL, maybe even DOCA if we want to program DPUs at some point in time. And the MPI section should be renamed to MPI and MPI libraries and collective communication. And up above CUDA also should be changed to CUDA and
Let's see, where was that? CUDA, change it to CUDA. And sorry, what was your suggestion?
CUDA and NCCL.
Okay.
Because later, we will see like Meta's extension, which is called NickelX, and other people. There are a lot of people who took the basic idea of nickel and then tried to make it work outside NVIDIA context. Yeah, we can
Okay.
I don't know much to say about ROCm. I don't know if people are having thoughts about ROCm.
Well, hopefully somebody from AMD can provide some input at some point, or somebody who's familiar with it, ROCm.
And I think we also, Jason, in 3.72, we wanted to also mention Doka here in this proximity. So maybe we want to call it CUDA, NCCL, and Doka. Doka is their API for programming DPUs. Okay.
Great.
Happy
Any
with
others?
yeah.
Yeah. Any other suggestions? All right, I'll kind of scroll back down. I'm trying to remember if there's anything after data formats. We do have, Pankaj, you'd put your name next to arrow and substrate, but I understand there's a lot of sections to write here. So certainly if there's anybody else, we got OpenXLA again under compilers with Garov and also Glow. Let's see
Who
what
put
else we have.
IREE and who owns it?
I don't think we have an owner right now.
What is IREE?
I'm not sure I know. I think that was something from the original outline that we kind of inherited. I'm not sure I have an answer for that. Does anybody know? Maybe, I don't remember how I did the strike through.
Yeah, so it says that IRE uh, is an open source ML compiler and runtime designed to take ML models that run efficiently on diverse hardwares, CPUs to GPUs. So open source, the machine learning compiler and runtime. Google
Is this
pioneered it first. Yeah. First, it came from Google, I think. Yeah. Then they open sourced it.
so? Question is which has more pulse in the GitHub? Is it IREE or interesting article from 2023. Let me share this with you guys.
Do you want me to stop sharing for a second?
Yeah, for a second.
Okay.
Thanks, Jason. See what it says here.
I actually know quite a lot about IRE. So it's used, for example, by the platform, the Google NPU platform. And one company that's been using it a lot is a company that one of my former PhD students is working at. He's, I think, VP for research. It's called, it's the one started by Carver Mead 30 years ago.
Oh, in Pinch.
No, not in Pinch. No, that's Carver Mead student. Actual Carver Mead, it's called what is, oh man.
This is the company that was making
Synaptics.
Oh,
Yeah.
touchpad company.
Yes. So Synaptics, which they basically use this IREE for their platform. So it's basically an intermediate representation and for machine learning. And the big advantage is that you can have an orthogonal. So basically, you can go on at any AI kind of PyTorch or TensorFlow code and compile it to arbitrary hardware
Mhm.
by and using IRE as the intermediate representation. So that's why it's an MLIR. And you just need to write the targetable parts for your custom accelerator if you have one. And that's what they are doing at Synaptics.
And I'm so jazzed that you are here and you know a lot about it. So can you kind of catch up on the status of uh, joining and then leaving OpenXLA? It would be good to know where this is at and which one is has more polls, or are they both worth tracking, or one is better than the other? Can you make an assessment together with Gaurav and Srihari and kind of let us?
Yeah, maybe we need to get together because I don't know much. Well, I know from this again, just because my student works there and he basically came and gave a talk at UVA and we discussed a lot. And there is actually a compiler called Torque with a Q, TORQ compiler that's built on top of IRE. So yeah, I mean, I'll be happy to try something, but yeah, I'm kind of vague about what exactly to do. Yeah. Again, the big advantage is that now with this, the Synaptics people can go to Hugging Face, grab any code from Hugging Face, and just run it on their hardware with all very seamlessly compile it and it would work. I'm not sure how that relates to what's going on here. I mean,
So it might be like compliant with Triton compiler, or
again, the actual there are many compilers that you can build on top of this IRE. Again, this is a representation, but the specific one that Google with Synaptics they actually collaborating on this is called Torque, the compiler. So yeah, I'm not sure again how specific that is, and we are trying to use it in my group, but we just started. So I don't want to derail the discussion, but since it came up,
no, this is helpful. I think since this is in the document right now, and you are the one who knows most about it, what we want to do is make sure that it is relevant to the larger goals of the project, which is near memory compute and near data processing. And then if it is, then let's at least position it with the principles that we like, right? What does it represent? And, do we want it instead or in addition to OpenXLA? That kind of question arose in my mind.
I'll try to look. I don't know much about the OpenXLA. So I just put a link in the chat if you want to read. I mean, again, it's just kind of marketing, but it kind of talks about Synaptics, Google, Torque, and this Coral NPU.
And Pankaj, to get the information, the question that you asked about the status, here I'm posting a link in the chat window. I think these days it's easy to check, the activity on a project, on a community project.
Yeah.
So like for OpenXLA, I think, or maybe Jason, you want to pull that up, the link I just posted.
Sure.
It says 550 pull requests.
Yeah, I mean, you can see how many contributors there are. So, and what is the status like? There are about 800 contributors currently on this, and actually, what's the activity over time?
Yeah. Can we see, is there a GitHub for the other activity, the IREE activity?
Yeah, I mean, we could search GitHub IRE if it is there. Apparently, yes.
161 pulse, so it's not shabby.
Yeah.
So it didn't come up on my search, but maybe I didn't do it quite right.
Oh, here it is. Let me post that link. What I found.
Okay.
I'm not familiar with this, but here.
Yeah.
Okay. Too much of a good thing, but that's lovely. It seems to have at least community meeting recordings all the way through June 2025.
All right.
It seems to have, embraced Triton's programming model, so they're discussing things like tile programming, data tiling, etc.
Hmm.
In the most recent presentations and talks. They say go to our website for more information, which is website is supposedly iree.dev.
Oh, yeah, I see that, but then it's interesting. It's IREE-org here in the Git repository. That's weird that they have two different names.
Yeah, I think one issue with all these open source, things is that everyone forks them and does their own branch, and so it's hard to keep track. Yeah, I think that's what again with that Tor compiler, and they kind of forked from IRE and they embellished it and added some features that they were interested in. So yeah, it's not clear to me what IRE, pure really means and does.
But it
Like,
seems to be an active community.
oh yeah,
Most
yeah.
recent discussion is 2 weeks ago, and
Oh yeah,
so I think we need to pay attention. We just want to go back to the document, Jason,
Sure.
and leave it there, but want to assign an owner. And Mirshe, I would beg you
I
to
will
take
try.
this
I will
on.
try.
Yeah.
I will try to take a stab at it.
I mean, even if you just collect your thoughts and, we can help wordsmith and stuff, that'd be great.
Yeah, and if you can send me the link just to make sure that I have it, that would be, or send. Is it somewhere on the?
It's
Because
on
again,
a
I have
Google
not.
Drive. Yes. Yeah, it's
Yeah.
on a Google Drive that you should all be able to access
Okay.
because it belongs to the DCC group.
Okay.
So
Okay.
And Jason, we might want to capture the things that have showed up in chat and just stick them in this section so that we don't forget.
not a bad idea. Let me see if I can
Yeah.
capture that really quick. Yeah, sure. Let me paste.
Yeah, but just I'm sure there are many documents in that Google Drive. So maybe in the minutes, if you can put the link when you send the minutes, just for me to make sure that I'm not going to struggle finding it.
Sure, I will make sure you have the link. So this is kind of out of place here, but here we've got OpenXLA right here. Great. I'll capture this from Garov. Let's see. And then I can put this Synaptics link in here as well.
Yeah.
For anybody who wants to take a look at that.
Thank you, Jason.
Absolutely. So actually, I think we've kind of gotten to almost to the bottom of the paper. There is a section 7 with the architecture options, to device first and accelerator first, and it's got a lot of the content that you had shared previously, Pankaj, and obviously we can certainly update it if you feel like that makes sense.
Yeah, I added,
section 8 is a conclusion.
Jason, I know we are at the top of the hour, so we need to end. But I did want to, place a basic diagram So I did in 7.1. I kind of started to illustrate uh, how people approach where they think about, hey, I have a memory device or storage device, and can I just add something to the command set that is usually used with that memory or storage device to do some additional things. So you can imagine, how we did that in SNIA and NVMe for storage. We just added an NVMe command set, right? Now, in the age of memory, when University of Illinois did this for computational memory, like a paper I wrote with Namsung Kim in 2017, we described how they overloaded the load store interface with the shadow address space. So if you did load stores to the shadow address space, you were able to trigger computations. Okay, that was the approach. And the problem is that with CXL not specifying any computational programming interface, but allowing type 2 accelerator, the question is, do they want us to embrace that approach? Otherwise, how do we use the combination of load store and mailboxes to make things happen on the other side of CXL wires? And like, how do we call functions, and what did ARM do when they described their prototype to this team? But that's all an example of device first architecture. Okay, if you go to the next section very
So
quickly.
maybe, okay.
Yeah, the accelerator first architecture is you recognize that there is an accelerator in that device, and you use the standard mechanism that CPUs use to talk with GPUs and FPGAs like OpenCL library, or even better like CUDA library, or things with shared virtual address space to call the function and the memory resources behind the function, and gets used as needed behind the function. So this is accelerator first architecture. So it's important because then that will affect what is the way we want to approach API development. And I want to say I have a preference for this architecture in 7.2. Okay. Especially for memory world. Yeah. So I'm working on it and owning it, but if somebody wants, the reason I took time to explain it past the top of the hour is if somebody else is interested and has thoughts on it, I would love to collaborate with you on these two sections. So Jason, 7.2 should also have my name, but I'm very open to having a collaborator on this. If somebody is very interested, please join me.
Okay. Okay. All right. Well, I need to go ahead and switch over to another call now. Any closing comments from anybody? All right. Sounds good. Thanks for the great discussion today, everyone. We will meet again next week.
Thank you.
Thank you.